LandSat 8 imagery is just beautiful stuff, right? Like I have there's a 752 up here in behind my face, and it's gorgeous, right? We've got this really strong contrast between the fire scar. You know, we've been talking about the forest fire and such, and then we've got all of the other areas, and there's these streaming, you know, translucent clouds coming across the image. It's beautiful. We're going to work with band number 8 next, the panchromatic band, and we are going to use the panchromatic bands to increase the quality of the true color bands. And I say true color because the panchromatic band actually is a true color band. It's one band that has a really wide wavelength range. So the spectral resolution is crap, right? It's not very fine, it's actually fairly broad. It covers the entire visible portion of the spectrum in a single band. So, you know, if something's bright on the panchromatic band, you don't know what color it is. It's just bright, that's all. You don't know. So you would have to look at those same pixels on either the blue or the red or the green bands, figure out which one is the brightest, and be like, oh, okay, well, yeah, it corresponds. And that's the key word, corresponds. You cannot pan-sharpen bands that are not corresponding to the panchromatic band. It's just not done. I mean, you can, but it's meaningless. And the output is poor. You get absolutely poor results if you try to pan sharpen, you know, near infrared or short wave infrared bands. It's not done. You're not even really supposed to pan sharpen the coastal band either, because it's outside of the range. Let's actually take a look at the range. Right? I have a document here somewhere. Hopefully I didn't mess up something. Let's pause this. Hey, there it is. Right, the bands, right? If I look at the panchromatic band, band number 8, right here, and I can highlight these, you can see that we've got a wavelength range. That column in the middle corresponds to the wavelengths that are recorded on band number 8. And they correspond with the visible portion of the spectrum. The visible portion of the spectrum is 400 to 700 nanometers, and if we look here, we've got 0.5 to 0.676 micrometers, same thing. So this is 503 nanometers across to 676 nanometers. That's inside of the visible portion of the spectrum. So the corresponding bands are the blue, green, and red bands. If you look at band number 2, right here, it corresponds, right? The blue corresponds, and the green corresponds, and the red corresponds. Look at the numbers. 673 is the max for the red, and it corresponds directly with that panchromatic band. It's inside that range, so you're good. Anything that's outside of the range cannot be pan-sharpened. What is pan-sharpening? It's, well, you take the 15-meter pixel of the panchromatic band, and anything that's bright on the panchromatic and is also bright on other corresponding bands that have poorer or lesser spatial resolution, then you're looking at, 30-meter pixels on the red, green, and blue. Well, you can do it. You can turn those 30-meter pixels into 15-meter pixels, and that's the process of pan-sharpening. It's done relatively quickly. What you need in order to do pan-sharpening is a color composite that is a true color composite, and you need the panchromatic band. That's it. So let's do that. Here, what am I looking at? I'm looking at a bunch of composite bands. The outputs are right here. Let's do the composite bands tool again, just for some practice. All right, I'm going to get my composite bands tool. Composite bands, and I'm going to put in the June the June 13th image. Let's grab those. I have them somewhere around here. Here they are. I'm going to choose band 4, 3, and 2, and I'm clicking them in that order, holding down the control key, because I want the red to go into the red position. I want the green to go into the green position and the blue to go into the blue position. So band 4 corresponds with the red, and so on. So that's why I click them in that order. I'm going to turn off my I click OK. Those input rasters go in, and I don't have to do anything with the panchromatic channel yet. I need a true color band combination as an output. So let's give it a name. Instead of B1 to B7, right? That's what we were doing with all 7 bands. Let's just call it B432 in that order. The environments, I'm going to say, let's bump up the processing, build some pyramids, compress them, and also resample using bilinear, and that's it. I'm going to run. This will take, under a minute, and it's not too bad to do that. So while it's running, I'm going to pause. Okay, it's finished, and here it is, right? So we can look at it, and it's fairly dark. So let's quickly just, again, go through some quick enhancements. So I'll do a % clip, and we'll go with nice as wide as we can for the histogram, so that it's not super dark, not super bright. Let's go to this mask tab and get rid of the no data as black. Let's just make it transparent. And I usually turn the green down a little bit, and I also usually turn the blue down a little bit as well. How does that look? Happy with it. As you zoom in, you see that it's really pixelated, and we want to take these pixels and we want to make them smaller, right? Look at this island right here. I'll focus on this island. If we were to run a pan-sharpening operation, those pixels would get quite a bit smaller. Well, 4 times. You'd be able to fit 4 pixels within 1 pixel. 4 15 meters will fit within 1 30 meter pixel. Raster functions, that's what we want. The raster functions here, there's a drop down menu, or you can open up this window, is found through the analysis part of the ribbon. So let's grab our raster functions. Pan sharpening is found under appearance, so we're not going to do any analysis yet. In this course we will be playing around with some analyses. But let's go to appearance and let's play with pan sharpen. Right? The multispectral image that's going to go into the pan sharpening option has to be a true color, and it has to be this one right here because we've saved out of 432. So that's it. The panchromatic image, we're not going to be able to find it because it's not in the map. So let's go and actually find it. It is band number 8. Can I just drag it across here? No, I can't. I'm going to have to just open it. Pan sharpening type we've got as Esri. That's fine. And let's create that new layer. That's it, it's done. Except this pan sharpening layer. Now what we should do right away is just, I know it worked, I'm going to export this out. Okay? And I'm going to call it 432, but I'm going to put a little tag at the end of that and call it pan sharp, so I know what's what. And let's see what else we can look for. 16-bit unsigned, that's fine. No data value, leave that alone. Output is TIFF, compression, leave it alone. Settings, let's resample as always bilinear. Pyramids should be bilinear as well. And we can compress those with LZ77, and now we can export these out. So it's going to do its thing. This is going to take a few minutes, so I'm going to pause the video one more time. So now it looks like the pan sharpening has been exported out. So I'm going to remove this layer right here because it's not a permanent one. It's actually just a temp layer. This one here has been written to disk, so that's going to help us. Now let's obviously work with the symbology to make it look a little bit nicer. So the stretch will go with %clip, and obviously the min and max need to be matching. So let's take this down a notch. Oh, I'm going to have to bring that up a little bit. There we go. Gamma for the red we'll leave alone. We'll bring the blue or the green down. We'll bring the blue down as well. That should be relatively good. Now, when I zoom out, you're like, well, it doesn't look that special. But if you remember what the other one looked like, this is actually pretty neat. Watch this. This is pan sharpened, and our pixels are 15 meters. Do you want me to prove it? Yes, of course you do, right? So let's zoom in on a couple of pixels and measure them. It looks like about 15 meters by about 15 meters, right? And if I turn it off, you can see that, oh yeah, well, there's your 30 meter pixel, right? So how does that work? What does it look like? As I zoom out on these 30 meter pixels, that same island, hey, not looking so great. If I turn the pan sharpened one back on, oh yeah, now you can see. So that's all I'm trying to do, is just show you what pan sharpening does, and show and really, you know, you don't notice it that much when you're zoomed out to, you know, really small scales, but it's pretty fantastic to use it and to see what it can do. It's a relatively shallow lake here, pretty cool. Lots of sand. So let's go here and let's see if the effect is really as impressive as you would think. I just turned off a few windows, and there's this swiping feature that I really absolutely love. So we're sitting at a scale of about 1 to, let's go to 40,000. Because on a pan sharpened image, that's about as close as you can zoom in. On a pan sharpened LandSat8 image, that's about as close as you can get. And there's this swipe feature on the appearance tab when you have an image selected in the contents pane. So if I activate this swipe feature right here, you can see that you can click and drag to reveal content that's hidden underneath in the drawing order of the contents pane. In 2D, you can swipe across any layer, including features and imagery layers. In 3D, you can do the same, such as you know, swiping across to expose different shapes and buildings and such. But we're in 2D, obviously, so let's activate it and see what we get. We get this black triangle, and we can swipe from below, right? And we can also swipe from the side. And can you tell the difference? I think you really can. At 1 to 40,000, right, you're zoomed in and you're not seeing any pixelation or any degradation of the spatial resolution of the image, right? But you would have to zoom in quite a bit more to really see how much better the image is compared to a non-pan sharpened image, right? So, you know, there's some other features happening. Here's a golf course. That's kind of cool. The golf course itself can be seen clear as a bell on a pan sharpened image. What about on the non-pan sharpened image? What do we see here? I think we can still tell that it's a golf course, but is it a golf course, or is it just a pile of beans on the side of the road? Yeah, no, that looks like a golf course to me, and you can even see where the where the sand traps are and all of those things. It's pretty cool. So pan sharpening, right? LandSat 8 imagery, beautiful stuff. It's free. What a beautiful way to play around with imagery, right? And it really cleans up a lot of the line work, and especially in the roads, right? Now, the Word document requires you to show the difference between pan-sharpened and non-pan-sharpened imagery using two side-by-side screenshots that are comparing the same thing, right? The same location. So, you got to go and find something that can be compared across the two images, right? And that's what you're required to do. So, that's what I will do. I'm going to go and find something interesting to look at. Maybe I'll grab this area here. Whoa. I'm not really too worried about what scale you're at. You just need to be able to see the definite differences between these two things, right? So this is pan-sharpened and this is non-pan-sharpened. So let's grab our non-pan-sharpened first. Print screen is my screenshot. I'm just going to pop it in there. Then I'm going to go back, and before I even do anything else, I'm going to turn on the panchromatic. Print screen, grab it, and I'm going to go over the Word document and throw it right underneath. Okay, so we have two right beside each other being displayed, and you can tell the difference quite easily, in fact. So these screenshots are required, and you probably want to clean them up a little bit and say, oh well, I'm going to crop, not resize, crop things so that we can see what's happening in these images. Make them small enough so that you can fit them beside each other. And also try to do an apples to apples thing, right? So right about there, right about here, right here, and right about there. Why can't I fit them beside each other? I don't want to crop them anymore. Maybe I can make them a little bit smaller.